Welcome back, Matt 1140, Career Math. This is chapter 17.1, Lines and Angles. Now, these notes are a little longer. I have included some of the information from the textbook, and I wanted to make sure you had all of the vocab you needed. So, as always, objectives are at the top. Use various notations, blah, blah, blah. You guys can read those. I am not reading them to you, okay? First things first, we want to make sure we identify parts. Okay. Now we have three terms in geometry that you can't really prove, but we use for everything else, and that is a point, a line, and a plane. So let's start with those. And I think I have point and line on here, but I didn't put plane. A point is just a position in space. So it represents one spot. That's it. Okay. We name them with capital letters. You can see them named with other stuff. That is fine. We're not going to get that picky, but typically it's a capital letter. A line is infinitely many little points all strung together in a straight path. Okay. So whenever we talk about solving an equation or the equation of a line, when we're doing this algebraic, any point, one of those infinitely many points on the line are going to make the equation true. When we name a line, doesn't matter which direction the points go, but take a look at the symbol here. We have this little line symbol above 2 points on the line. Okay? So if I had another point over here, maybe there was a C. This could also be a C. There is no magic to which points we choose. CB, we can go the other direction, all work. When we have a line segment, means we have a part of a line. A line segment has endpoints. It's got to have a start and a stop, if you will. Notice it looks like the symbol for line, but we don't have those arrows on the end. The arrows say that we go off infinitely in both directions. The lack of arrows means I start at A and end at B. Could also have called that gone the other direction, right? BA. Direction doesn't matter here. Direction does matter when we talk about rays. So a ray has to start at an endpoint. And that is the first point we list. So this here, starting at A, going through B, that's the ray AB. So this would be a good time to pause. Take a look at this example. This one came out of the textbook. And see which of these you can answer. A, name a ray with an endpoint of Q and passing through P. So let's take a look. Endpoint of Q passing through P. That means I'm starting at Q, I'm going in this direction. Now that could be, I didn't really leave myself a whole lot of room here, QP. It could also be QM. Because going through P, going through M doesn't matter. It just means it goes off infinitely in that direction, does not end. Okay. Next question. Do LM and MN represent the same line? So here's LM, right? It's a line. We are not starting and stopping. Here's MN, same line. So that one's a yes. Do PQ and QP represent the same line segment? That is also a yes. We've just reversed the endpoints. That's okay. Two lines that are parallel lines never cross. And so here, even though they're not marked as parallel, these are the two that don't cross, RS and PQ. Or PM or MQ. A. QP starts at Q and continues indefinitely through P. It is different from ray PQ. That's a yes, that's a statement, not a question, but whatever. QP we have highlighted in that teal. Let's pick a different color and take a look at what PQ would look like. PQ starts here and goes this way. There is some overlap in the middle, but those are two different rays. Different starting point, different direction. Oh, looks like these are the answers on the bottom. Apparently I was not paying attention when I cut and pasted that. So there we go. Page 1. Page 2 dives into angles here. An angle is formed when we have two rays that intersect at a point. That point is called the vertex. Okay? So angles can be named with a single point. So in our case right here, this picture, there is no confusion about angle X if I call it angle X. And you may see this little symbol here. Sometimes it even has an arc through it. That just means the angle X. 3 points. When we talk about 3 points, we go from one leg through the vertex to the other leg. So YXZ or ZXY, both of those name that same angle. Sometimes we'll have it labeled with a number, angle 1. A lot of times you may see it with a Greek letter like alpha. As long as there is something inside there to call the angle, we can name it with whatever it's labeled inside. Angles are classified by their size. Acute angles, and this diagram says less than 90, it actually has to be between 0 and 90. Cannot be 0, cannot be 90. A right angle always equals 90 degrees. I guess I should put degree symbols over here. An obtuse angle is bigger than 90, but less than 180. So obtuse is not just any number bigger than 90. A straight angle, and this is the one term you may not have heard before, is just a straight line. So straight angle is a straight line. And we use that 180 degrees to come up with angle measures when I've got two angles shoved together that make a straight line. Example 2, this again would be a good time to pause and answer whether each of these is right, acute, obtuse, and straight. I don't know why I put them in that order. But anyway, A, between 0 and 90, this is an acute angle. 95 is obtuse, it's bigger than 90. If it equals 90, it's a right angle. Again, D is 153 between 90 and 180, that's obtuse. And 0 degrees, I put this in here, this is actually not an angle. All right, there's gotta be some sort of opening between those two rays. There's special angle relationships that do things for us. We can have angles that are supplementary. Measure of angle A plus measure of angle B, whatever those numbers are, supplementary angles always add to 180 degrees. If I have adjacent angles, just means they share a side. Sometimes we call that a leg. But if I know the total measure for the two angles combined on one of the angles, I can find another. So we can add measures to get a bigger angle. Complementary angles, we'll call these ones C and D. Complementary angles add to 90 degrees. The other angle relationship we are going to look at are called vertical angles. Vertical angles are the opposite angles when two lines intersect. Vertical angles are always equal. And so I'm going to put measure of angle 2 and measure of angle 4 just so we know we're talking about the numbers and not specific angles. If two straight lines intersect, we should have two sets of vertical angles. Example 3, we're asking if these angle pairs are complementary, supplementary, or neither. Again, you can go ahead and hit pause here, give them a shot, and then come back. To determine whether something's complementary or supplementary, I've got to add them together. So I'm just going to go ahead and add these. This is not 90 or 180, so this is neither. When I add 17 and 73, 7 plus 3 is 10, 7, 8, 9. These are complementary. Notice it's complement with an E, not complement with an I, which means we're saying something nice about somebody. C, 142 and 38. Again, I'm adding old school. They add to 180. These are supplementary. And the way that I kind of remember it is 90 comes before 80, 90 smaller. C comes before S in the alphabet, so complementary comes before supplementary. Complementary goes with that 90 degrees, supplementary goes with the 180. Whatever it takes to remember it. D, 52 and 48, and this is a common mistake. A lot of times we will look at that 5 and 4 and C9 and ignore the 2 plus 8 part. So be very careful when you look at these. This one's neither. They add to 100. If two angles are the same size, they are called congruent. We can say angle A congruent is the equal with the squiggle on top. If we are talking about just the numbers, measure of angle A equals measure of angle B. Sometimes you'll see it like this. Measure of angle A, measure of angle B. Those both mean the same thing.